show you how the convolutional neural network. So this another type of neural network. It is not like dense neural network. We just use it now. This code, guys, we use it in dense neural network. This one, I will come back to this when I make comparison between the convolutional neural network and dense neural network. So I will go here. 1 second. You will find convolutional neural network and convolutional neural network for images. All right. So here in convolutional neural network, we will cover what is a convolutional neural network, how to make convolution layer, what's the kernel, what's the parameter, something called the pooling, what's the dense. Okay, this is the point, guys. Let's understand how the convolutional neural network works. Guys, this is the data, this is the image right here, with maybe with the full resolution, not necessary to be a small image. Okay, you're here. Okay, now I will put some filters. One called the filter. This filter here, right? This is like 3x3 filter, and I will move it this way. I will keep moving this way. What this filter can see, this filter, guys, can tell me what exactly here in these parts. So how this filter work? Let me show you how this filter work, guys. Okay, I hope you understand this part. Let's say we have filter called the X. Let me.
Yes. Oops.
Can you mute your
Yeah, sorry about that.
Right, but here for this I will come here to show you how the filter do. I will add and let's say we have this image, and this image, of course, guys, is just numbers, right? That image, and this image is like array, number of rows and number of columns, all right? Okay, this is my image right here, and I have something in my hand here is called the filter. And what this filter is, this filter, guys, let's say we have a filter 3x3, and this filter 1, 1, 1, 1, 1, 0, 0, 0, 0. And I will take this filter, guys, this filter, and I will move it here. So look here, guys, I take this filter. Now I will put this filter here. You got this? There's a filter right here. And then I will move it. Oh, do I have a chance to move it? No. Yes, look, guys, I'll take this filter and I move it. So when I move this filter, guys, all right, look. All right, so I will move this. Look, guys, I move it, and then I moved again, and then I moved again, and then I moved again. This is called the convolve. Convolve means moving. So I may move it, and I move it, and I move it, and I move it, and I move it. Okay, this convolve. What exactly happened here? Let's say, guys, let's say in some particular part, right? This first part, this part give me, it has these numbers, right? 1, 1, 0, 0, 1, 0, 0. Let's see 1 here and 0, 0, 0. Okay. When I put this filter on this part of the image, can we make multiplication? 1 times 1. Okay, guys, 1 times 1 give me 1. plus 0 times 0 give me 0, plus 1 times 1 give me 1, that's 2 now, 0, and 1 times 1 give me 1, that's 3 now, 0 times 0 give me 0, 0 times 1, 0 times 1. So the output here, it will be 4. The output will be 4. When I multiply all these numbers on this filter. You know what that means? That means maybe here is the X. What is the X? Because guys, this filter actually represented this X. Okay, represented this X. Okay, guys. If you make pixel 1 and pixel 0, this means it's white and this dark, this white and black, and this white, black, this X. If we multiply this filter here and give me big number, that means probably this place has X. What about if doesn't have X, guys? Look like this. What about if this number is 0, 0, 0, 0, 1, 0, 1, 1? If you multiply this place, this receptive field, what's it named, receptive field, with this filter, 0 times 1 plus 1 times 0 plus 0 times 1 plus 0 times 0, 0 times 0, and then give you 0. It gives you 0. You know what that means? That means this area has no X. Correct, guys? This area has no X. But if it has X, it will be has a big number here. So I'm keeping moving this filter to to find a specific thing. Sometimes I just want to see if it in this area has a horizontal line or what. What the horizontal line will be? 1, 1, 1, and 0, 0, 0, 0, 0, 0. What about if I'd like to test if it has vertical line? If it has vertical line, so it will be 1, 1, 1, 0, 0, 0, 0, 0. What happened? I will keep putting this filter on the image and I'll keep moving this filter, the image like this, convolve. So, and I will keep calculating the number here. This number here, it will names feature extraction. I extract the feature. Okay, let's make it easier, guys, by another example. Look. I will come back to this, don't worry. This example right here. Okay, so this is a filter here. It's called X, this X, guys. And this a part of the image here. And then I put it in the first part of the image. I'll call this perceptive field, perceptive, and this is a filter. I'm trying to find if this part of image has this X or not. 1 times 1 plus 1 times 0 plus 1 times 1 plus 0 times 0 plus 1 times 1 plus 1 times 0, and so on. Give me this 4. Now I will move it. You guys, I move the filter here. And I keep multiplication with this part of image. Give me this. And I keep moving, keep moving, keep moving. Right? So what happened here, guys? This is the image. And this is the filter. And this is the feature. If I have big number here, that means I probably I have in this area X, but small number, that means wouldn't have X. Of course, and this for any other filter, like vertical line 1, 1, 1, 0, 0, 0, 0, 0, 0, or horizontal line, horizontal dash 1, 1, 1, 0, 0, 0, 0, 0, 0, or like slope the line 1, 1, 1, and the other equal 0, and so on. So what happened here, guys? I'm trying instead of basing all this image to the neural network, no, I will add some filters. Each filter represents a specific feature, horizontal line, some abstract feature. Okay. And after this, I will keep convolving the filter in this image. That's way to discover what's inside here. and the output, it will be here. This, it will be image, but smaller size. It will be image as well, smaller size here. Okay, all right. So this what's called, when we apply filter here, this give me feature map or feature direction, feature map. All right, all right. So this about convolutional neural network. Actually, convolutional neural network, we have the image here in 2D, and we have filters. This is what we call it, conv2D or convolutional layer. And then we have something called the max pooling. I will come to this, and I can keep doing this convolutional plus max pooling, convolution plus max pooling. And then finally, the last thing, I make flatten, and then I give it to the density layer. Sorry. Density layer. Finally, at the end here, for the output here, I have something, activation function, softmax, to why? To classify this image, if it is bird or sunset or dogs or cat or what. Okay, so these are 4 parts of convolutional neural network: convolutional layer, polling part, I come back to this, and density layer, which is for connected layer, and output layer, which is softmax. All right, I will come back to this, don't worry, guys. All right, so for this image, actually, it actually is not, the computer cannot see image, it see it like a matrix like this, right? But because, guys, this RGB image, it is just not one matrix, 3 matrix, okay? 3 channels, one for R, one for G, one for B, RGB, okay? Right? So we try here to tell you what's the problem with the last model, the last neural network. We do flatten for the image, but when we flatten the image, it will be vector what vector, it will be a long vector pixel and lose all the spatial structure of the image. Is right? Unless all the image are perfectly resized and cropped. If the whole image resized exactly, and let's say that the density neural network can be good, could be good if the image exactly look for the same thing. If we try to see the dogs, so the dog take the same position, look onto the camera, same position exactly, same crop, okay. But if the dog look like this and away like this or something, or the density neural network will not accept or predict them correctly. But convolutional neural network don't care. If even the dog moving through the image, no problem. Anyway, I will convolve and define the feature, right? So what the convolution can do in convolution layer, guys, we try to find abstract feature like dash, like something, and then I will connect them after this in another convolution layer to find a part of image and then a big part of image, and then I will classify the image. Okay, so here it will be more abstract than the after. Okay, so convolution neural network depend on 2D, not in 1D in this one. All right. So because the flatten was a problem with the problem with the flatten, it is lose for the spatial location of the structure of the location. Okay, so convolutional neural network can find the spatial relationship between the pixels. All right. So how to learn the feature? What does the feature means? The feature means for abstract, what is the slope the line, the vertical line, the horizontal line. After this, the feature will be a part of image, eyes, chin, cheeks, ears, and this will be the line. Okay. All right. So I will come here, this specific neural network. What we do here, guys, we do convolution neural network and pool and convolution, and pool, and finally flatten. Then we have dense layer. Dense layer means the full connected layer, and in the output layer we have here softmax. Softmax is a tell me. Okay, guys, tell me 1 second. Sorry, softmax. If this 1 and 0, 0, 0, that means this is a bird. 0, 1, 0, 0, that's the sunset. 0, 0, 1, 0, it will be dog. 0, 0, 0, 1, it will be cat. Okay, that's what the softmax do. Softmax is good for multi-classification. Okay, so this is a filter, guys. So this filter. So the filter here should be 3 times 3. Filter has another name. It's called kernel. How to do this filter? To create feature map. I don't understand. I will come back to this, right? So this filter, okay, size 3 times 3, right? And I will apply to the image to create this feature map. How many features we need? We need many features. So we need to create many features. Okay, the feature map is the first feature map. Okay, after this, guys, look in this example, the kernel or feature is called filter. Sorry, the filter shifted 9 times. The kernel can be initiated randomly. So this number could be random, all right? No, not this one. This one be random, all right? And many things. And we keep teaching our model what's in this image using these. Right? What about if I have RGB? We have RGB like this. RGB. Guys, before I go this, did you understand how this filter predict X inside the image? So if this high number, this means in the edge of the image there is X. Let's say the other equals 0, so there's X here and no other, there's no any other X. If I'm trying to predict just the or is it a vertical line 1 1 1 0 0 0 0 0 0, I will apply it here and I will keep convolving, moving step by step, step by step, step by step, step like here to complete the convolved feature, or this called the feature map. So I can know exactly where is the vertical line exists in the image. Where is a spatial data. Spatial means into the location. Okay. What about if I have big image to this image, RGB? Can I apply filter? Yeah, I can apply filter. One filter, yes, one filter. But also the one filter contains three channels. All right. Okay, guys, I take this image and I make it 3 times this 3, and I apply this kernel channel, the first channel, second channel, third channel. So these are 3 channels. This is the image RGB and this RGB for the filter. Okay, and I will keep. I apply this filter here, and I apply this filter here, I apply this filter here. So it gives me these numbers. This number. So if I have high number, I will know this filter exists in this base of image. Okay. All right. After this, we have a feature map. It's the output of one filter applied to the one layer. Okay. So we're done with this. Okay. So what about this? What is the receptive field? Receptive field, which is a part of the image, could be 3 times 3 or 5 times 5, 7 times 7, according to that's the receptive field, guys. According to the size of the filter. Right, guys? All right. What is the stride? Stride, the step. Okay, I can take one step, or I can, yeah, this one step. So the one step can 1 second, guys. The one step will move. 1 second here. Move the image. Can I use bin here? No bin. All right. I can look here, guys, as a step. A step here. This is called stride equal 1 because I move one step like this. But if a stride equal 2, if I'm here, I will do this one. Okay. If a stride equal 2, if I'm here, I will do this. So I will be, if I am here, I can do this one time. 2 steps. This is called stride. Stride, that means how big your step, all right? Equal 1 or 2. If this, yeah, is in this case, sorry for here. Stride here equal 1. Right? 1 second, yeah. but we can can make it 2 or 3, and this tuning to hyperparameter. So I will ask you to tune the hyperparameter. If I ask you this, it will change the style. I will show you how to change this in the code. All right. So the filter are feature detector. Detect if there is it is a vertical line in this space or not. Feature detector. Right. So I will detect if the vertical line here, if the slope line here, of the image here. Okay. If I like the image, the one filter look like this. One, 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 and 0, 0, 0, 0. You know what's try? This filter try to detect anything look like this. Okay? Because if I have the image, and sorry for this bad thing, but if I had some numbers here, and this number, okay, it is 1, 1, 1, 1, 1, 0, 1, 1, 0, and I apply this filter. This filter, guys, I apply this filter in this position. So 1 times 1 plus 1 times 1 plus 1 times 1 plus 1 times 1 plus 0 times 0 plus 1 times 0. So it gives me a big number. That means in this area, this we can find this shape. Also in higher layer, we can find a nose, an eye, an ear. Okay, of course. So this a number of filter or feature map. Look, guys, I'm trying to detect this or this or this or this or this. So small things we try to. So in this image, if I apply this filter, in this image, I can get image like this. So what happened here, guys? I convolve this green one, and I move it here, move it, move it, move it, move it, move it, move it. It give me this image, the one in the back. In the yellow one, I convolve it, move it, move it, move it, move it, move it. So we have different filters. So each filter can give me more information. Look here, the information in this area different than the information in this. Why? Because I apply multiple filters. And these filters could be randomly chosen, right? What is the padding is? The padding is, guys, look here for this image. If I come here, this image, let me tell you. This image, guys, if I apply this image here and I move it like this, the edge here, we just use it one time. But this line, this one, use it more than one time. Okay, guys? So to understand more about the edge part, we need to add something. It's called the padding. What is the padding is? Sorry, guys, this is not my, I add some zeros here. So if I apply the image here and then move it here, so the edge part, we learn it twice, two times. I can add more padding like this. But this called the padding equal 1. Padding always equals 0 here. But what's padding equal 1 is? That's one layer. Can add one more. Okay, so that's about padding. All right. So what is the stride equal to and padding equal 1? This one. Look here, guys. This padding equal 1. So I have this layer here around it I can use edges more than one time. So stride equal to, that means after here, I will move from here to 2 steps one time. So the second step, it will be started. Okay. Okay. The valid padding, same padding. Padding means, look here, guys, if I move this twice and twice, it's okay. But this is valid. Sometimes it's not valid. What that means? Sometimes if I move, let's say the padding equal 3. Sorry, the stride steps equal 3. Instead of here, I will move here. Second step, I will move like this. This is not legal. This is not valid. So that it was here. Second step, it will move. This is not valid. This is what we call not valid padding. But we need to we have two feature, valid padding and same padding. Same padding means valid padding like this guy. Look here. Look here. So I will move here. Image. And stride, the step is stride is 1. So I need 1, 2, 3, 4. So the image is come like 3 times 3. Filter was 3 times 3, and the image why 3 times 3? Listen to me, guys. I don't know how to do this, but how to add something here. I didn't find it. I'm just try to find something. Okay, I will take this copy. I can say this copy. It is. Okay. But doesn't take copy. Yeah. Can I save it? Copy, right? Okay, I will draw it myself. I think I can draw it with circle. Okay. Okay, so let's say the filter here 3 times 3. Okay, so I don't need to make it here, guys. The filter already here. I have this filter right here, 3 times 3. So each number here multiply the number here. So it gives me just one value here. Correct, guys? Give me this value. Now I will move the filter to this area. 1 is equal 1. It give me this value. Now I will move it stride equal 1 again. It give me this. It give me this value. You understand, guys?
Yeah.
Okay. So if I move it now to down here, let me change the color now. The filter here times this is filter, give me this value. If I convolve it here, the stride equal 1, give me this one. If I move it to here, give me this value. All right. If I'm here, give me this value. So the filter 3 times 3 and the output will be 3 times 3. That's what we call valid padding. Okay. All right. What about this valid? Okay. What about the other one? The same padding. This is the image right here. 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5. We add padding. Why? Because we need the result. It will be the same image again. 5 times 5. How come this? How can we do this? Okay, take this filter, the 3 times 3, and start from here, guys. All right, and then move it 1, 2, 3, 4, 5, 4. So it gives you 5 times 5 again. This is called the same padding, and this is called the valid padding. You don't need to bother yourself with this because, guys, this will be done by the code, by the Python. All right. All right, yeah, I think this will be more this one. Look here, guys. We move here, the 3 times 3, it to give me this value and this value to give me this and so on. All right. All right. What this is stride equal 1. Look at the stride equal 1 with the output. You got this, guys. The red one, it will be here, and stride means a step. Give me this. And stride. What about the stride equal to? Look here at the red one. Look at the green now. It's 2. So the feature map, it depends on the how much stride and how much padding here. We can make padding equal to like this. All right. This equation, how to do this, but don't care about the equation at all. We don't need to do this because the Python do it for us. Keras do it for us. Okay. Now, for now, after the input, we make convolving. This is called the conv which applying multiple feature on the image to give me multiple feature map. All right. And then I will use something. It's called the pooling. What's the pooling means? Pooling means this mini feature map right here. I will minimize its size. Okay, how to do this? Okay, I will tell you how to do this now. We have 2 types of pooling, guys. We have one is called average pooling and max pooling. Actually, if all people depend on max pooling, and I would like for you to depend on max pooling. But what is the difference? If we have this feature map, this feature map came from the convolution layer. I will take this 2 times 2, and I will take the maximum value of it. This one, the maximum value here. This one, the maximum value here. This one, the maximum value here. But the average, it is the average of these values. The average of this, the average of this, the average of this. Now you can ask me, what is the importance of pooling? Actually, I see 3 reasons I'm using pooling. The first thing, to minimize the number of calculation, because the image will be big. I will make it this from this big to this small. Okay, this will be 25% of this image. Because if the pooling is 2 times 2, maybe the pooling is 3 times 3, so it will be about 11% of the image. So minimize the number of computation. This is the first thing. What's the second thing? To highlight the feature. Imagine with me, this is a feature, and this some noisy around the feature. So I will choose just the feature here. I'm highlighting the feature. Number 3, to remove the noise. Here. So we have 3 main reason why I'm using max pool or pooling at all. The first one, to minimize the number of computation. Second one, to highlight the feature. The third one, to reduce the noise. Okay, or to delete the noise. Okay. Now, so far, we study how to do this convolution layer and how to do this pooling layer. Conv layer. What these guys, we add some filters here on the image, so it gives me this feature map. Another feature, convolve another feature, give me the other feature map. Another feature to give me another feature map, and so on. Okay, so the feature map here is the output of applying the kernel or filter and kernel, same thing on the map, on the image. Okay, after I finish with the conv layer, I can apply multiple conv layer. Okay, but after I finish with them, I should give max pool or average pool, the pooling layer. What's the pooling layer? I will take 2 by 2, and I will take the maximum or the average. I can take 3 by 3, yes, and take the average. What the pooling do? The pooling minimize the number of computation. So this is my image now, not this. This is the first thing. What's the second thing? The second thing, guys, it is highlight the feature and reduce the noise. Okay. After repeating this, maybe you can repeat this or not repeating. After this, I will the image, I will flatten this image. Why? To feed it to this neural network. So that's what I mean here. After pooling, we need density neural network, right? So sorry for this. I keep going back to this. Look, guys, each filter for this give me this feature map. Another filter give me another feature map. Another filter give me another feature map. And all this filter map is output of applying these filters on this image. And then I make maximum of these feature maps. I will take 2 by 2 and I'll take the maximum. So I can minimize this image and make it smaller image. Well, this image, it will be better. Why? Because we reduce the noise, maybe some noise here. And also to highlight the feature. Okay? We talk about padding. What padding? The zeros around the image. Okay? To do what? To enable us to find the feature in the edges here. What the padding? The step. What the padding? The stride. Sorry. The stride is the step. All right? So what is good for? Yeah, just how you convolve your layer. You know, guys, imagine yourself, you have like flashlight, okay? And guys, you have the flashlight and I'm trying to find something in the image, okay? I'm trying to find something in the image, okay? So I detect all the horizontal line in the image. So when I detect the horizontal line in the image, give me this shape. I think this horizontal, I don't know. Look like horizontal or vertical. And this looks like green. Oh, yeah, he says this. He says this is this. And the green one is this. Right? Okay. Please go back to this again. After I do this, don't forget to apply after the convolutional and pooling. Look, guys, conv and pool. And conv, what is conv, guys? This feature map. Where did feature map come from? Some filters I'm applied to this image to give me this feature map. And then pooling, make it smaller like this. And I will add some more feature map. Some more filters or some more kernel. Kernel is a filter. Okay, so it gives me some more feature maps. I will make maximal again. And finally, I will flatten all this to feed it to what? To dense layer. Dense layer means a full connected layer, like old one. And then the output and maximal. Of course, in each layer here, we add activation function. What is the best activation function we use? ReLU. Why? Because ReLU avoid us from two problems. Okay, the first problem, exploding the gradient. What that means? That means the weight, when you update the weight from layer to another layer, it will be bigger, bigger, bigger. So your memory cannot handle these biggest numbers. Or vanishing the weight. What that means? That means you apply the weight and times a half, times a half, times a half, it will be smaller, smaller, smaller. So there is no learning. So vanishing gradient or exploding gradient, these two problems actually in back propagation, in all back propagation, right? How can we handle this? We handle this with ReLU. All right. Okay, so you use ReLU here. Can I use ReLU here? No. Why? Because here you try to classify this image. If we have five images, I will use max softmax. I will tell you what is softmax. I told you already softmax 1000 if it is bird, 0100 if it is sunset, 0010 if it is dog, and so on. Okay, that's what the max parameter. Look here, guys. What is the activation function? It is nonlinear, which is ReLU and exploding gradient and do you remember, guys, what ReLU looks like? I just want to make sure you remember what's ReLU like. I'm sure we talk about this. It was like this. It will be x or 0. X if greater than 0 and 0 otherwise if it's less than or equal to 0. So if the number is 0, is negative, your ReLU activation function will produce 0. If the number is positive, it produces the same number. Okay, this is good for the middle layers, not for the output layer. Output layer need to think about this so much. I will talk about this in the revision again, because if we have classification problem, it is different than if we have a regression problem. I talked about this last time. Okay, so this pooling here is that whether the pooling good, whether pooling good for decrease the computation, reduce the overfitting, and extract the dominant feature, the important feature. Okay. All right. So, and how to do it? We already did it. But this guy again, guys, how to do pooling? But this guy is the average pooling. Actually, average pooling is not so much common. The common thing is mixed pooling. So the average here is this one, and this average is this, and this average is this, and this average is this. Look here, guys. The pooling here 2 times 2, and stride equal to. Could be 3 times 3. Yes, could be 3 times 3. Could be stride equal 1. Yes, could be stride equal 1. Okay. But most of time you will find this number. All right. This makes pool again. 2 times 2 is stride 2, and so all this. Okay. Now look here. So the input layer, the input image here, 32 times 32, and I apply some features. So give me this, and give me this feature map, and I do maximum pool, and I keep applying, and I flatten to be one vector, so I can feed it to the neural network. And finally here we have softmax layer. What is softmax layer? Tell me if it belongs to class 1 or 2 or 3 or 4 or 5. 1 0 0 0 0, that belongs to class 1. This image is class 1. 0 1 0 0 0, this image is class 2, and so on. Okay. All right, big stride, not our stride. He say this low net. All right, this it was a very big step in the science of the neural network, because it is win a big prize, and you could, and this it could be recognized 200. Look, guys. 15 million image with the 22 different categories, different types of, yeah. So dogs, cats, window, laptop, cup, chair. This is how this stride is done. So you don't need to read about this now, but I will show you one more thing. What's the imminent? Okay, so I will show you this with the code, and I'll come back to this if you have any question. Right? Don't need to do this. All right, so I come here, open. Right here. Look here, guys. All right, let me no. I will keep this now for 1 second. I will open another one. I name it here, convolutional neural network. So here, I show you how to apply the convolutional neural network for the same data set we have before, dogs 1 and dog 2. Okay. So what's new here, guys? This is sequential. This something called conv2D. What's the conv2D? Convolutional layer, and 2D because the input it will be image in 2D image, and this max pool 2D, and then we need to flatten, and then to categorical for output feature, and then so of course for the final layers. All right. So, and I will use numpy and image here for image processing. So I have this image. So maybe you ask about this now. What this use? This just used to create this filter. It will be random numbers. This filter, or for density layer, or for density layer or convolutional neural network, we need random numbers for weight. Okay. So here, guys, this was normalized dog images. So this images was normalized. That means it is just normalized, means it's scaled, just scaled. So I need to convert it. So I don't have this, guys. I'm supposed to have it here. I don't have it here. Okay. So this folder, guys, has the same image in dogs1 and same image in x2, but it is already resized. All right, resized. All right. So we need to complete the first step. What the first step is? The first step is to convert it to the grayscale. The first step done now. Second step, right? I convert any image in this folder to numpy array. Okay, and I will embed it to x. Okay, I will embed y 1. 1 supposed to be 0, no problem. I will embed y here 1, and I will embed y here 2. Anyway, 0, 1, 1, 2 is categorical data. I will convert it to categorical data. All right. So the same thing here. What I miss here, guys, I didn't scale it. I didn't resize it. So I imagine this already resized. I'm supposed to have this image. Not imagine. That means I have these files resized somewhere. All right. Now, for the second step, I have x and y now. How to make the third step? Again, guys, this is scaled already. All right, and this grayscale, this resize it and grayscale. That's the first step. Resize it and grayscale is the first step. What I'm doing here, I will add it to the. I convert it to numpy array, and I will add it to x, and I add to y1. I convert it to numpy array and add it to x and y2. No problem about 0, 1 or 1, 2. Anyway, I will convert it to categorical. It will be just like labeled. It is different than this. Okay. Here now the step 3. I will convert x to numpy array and y to numpy array. But for x, when I convert to numpy array, I reshape it. Look, guys, here. I reshape it. Y, look here. This 1 times 128 times 28. And reshape to be simple channel width length, right? Okay. And here I will normalize it. So, and then here, and I randomize it here to shuffle the data, right? Okay. What's the big difference here we made here? Here is big difference. Why? Because when I feed the neural network here, the convolutional neural network, I don't feed it just one line. I feed it 2D. So this only different now between for data image processing in dense layers. Let me do this double. I will show the previous one. Open. This is the only one different here. This was the first step. There is step 2. And the step 3, this look here, there's the reshape here. I flatten. Why? Because in this dense artificial neural network, I need to be flattened. All right. But here in convolutional neural network, it will be 2D images. So I reshape it to be 2D images. Okay. And here I randomize and I did the same thing again and again. Number of class, it will be 2i now. All right. Okay, and then I will apply convolutional neural network. How to apply convolutional neural network? Look here, guys, sequential, and look, conv maximal, conv maximal. How many times? I don't say how many times. We don't have this restrict. Okay, and also we can make conv, but maximal. Any group of conv, any one conv or any group of conv layers should supposed to end with maximal. Why? It's not because maximal avoid the overfitting, reduce the noisy, highlight the feature, and reduce the computation or the complexity of computation. Okay, guys. What this means? This means I will use 32 filter. Each filter 3 times 3. The stride equal 1. The padding, we have 2 padding. Even valid or same. I use here valid. You can use valid one time and same one time to find out what is the difference between them. The input shape, because this is the first layer, you need to tell me what the input shape. The input shape is one channel times 28 times 28. Why you make it? Why you know it's one channel? Because I reduce it myself. Okay. All right. The activation function ReLU. All the layer I will use ReLU except the last one. I will use softmax. Okay. Here I need to mention 1 second. Here, guys, it's called data format channel first. That means when you talk about the data format, you tell me the number of channels, how many channels, 3 or 1, either 3 or 1. If it is grayscale is 1, it's RGB is 3. And then you give me the width and height. What if I said channel channel okay, let me do this. Data format channel first and channel second, channel last. What is channel last? It will be 28 times 28 times 1. So I just mentioned this to tell this it will be the number of channel and this the width and this the height. But another format, channel last, it will be, in this case, you should write here 28 times 28 times 1. This is not hyperparameter, that doesn't just format. Okay, look here, guys, this conv layer, and with this maximal. And maximal size is 2 times 2. So 2 times 2, that means each 4, I will take the maximum of them. I can make it 3 times 3. Yes, you can make it 3 times 3. This hyperparameter you need to tune. Okay, and other padding, and that's the same thing. I remember I take this copy and paste it here. But I changed the number of filter to this number. That's it. I remember this. So do we need to mention the input feature shape again? No. The input just in first layer, just like this. Look, guys, for this here. The input right here. But I didn't mention it again. Okay. I'm sure we talked about this last time. Okay. So here, this the stride. Again, here I can change the stride. I can change the value to same. I can don't change. Of course, don't change this because you already prepare your data that way. Okay. And after I finish this conv max, I need to flatten my data to feed it to density layer. How many density layer? Whatever you want. But the last one is supposed to be the density layer. It will be how many output, number of class. If we have 10 category, you need to differentiate between them. So we have our 10 y1, y2, y3, y4. And you use activation function softmax to tell you if this 1, 0, 0, 0, 0, it will be bird. 0, 1, 0, 0, it will be sunset, and so on. Okay, now I build my model. Now I will compile my model, just like here, guys, look. I will compile my model. Just after I build my model, I compile my model. And after I compile my model, I train my model, and then I will test my model in later on here. Oh, I didn't. I'm testing my model using these examples. Okay, using these examples. Anyway, he will test it. We'll keep this for testing. Okay, so here also I will compile my model. Since guys, this classification problem, we need to use this loss function. Okay, and this item is better and the accuracy is better. And here, guys, the same thing we done before with these guys, this training. And I will keep this part for test set, and I will do 20 epoch, and this Apache size. And I will draw everything. Now, what else after I finish this? I test my model using my Tim, my Oscar, my Bob, the data unseen. So only different we learn now is this. Okay. All right. Let me come here to show you one thing about CA2. and CE2 guys that we require to do just the 10 days after the CE1. Okay, so you need student will design and develop dense artificial neural network and convolutional neural network for the image classification. Each group, guys, is 2 students. Must decide what is the image data set, how to delete to find the image data set. You can just go to Keras. Oh, sorry, I mean Kaggle. Just data set. Let's go data set. You can go Kaggle. I think you already know how to do this, right? Because I asked you to do this in the first time. So you come here and you choose the data set according to image classification or something. Okay, and you find image classification of cars, image classification of something, but you need to find data set, not code data set. Okay, image classification for birds, image classification for butterfly, image classification for number. So you find this. Okay, so you choose data set. Where? I don't know where. I don't need this anymore. Okay, here. Okay, each group must register the data set they use. Okay, first come, first serve, and any student have image data set project. Okay, not use it here. And each group must submit the assignment, to the model page, and to register here, come here, and one of the group put his name and his number and whatever is, and he put the link for his data set. Okay. And what's your required, guys? You expect to have minimized 2 classes or 5 classes. It is not important because anyway, I give you now generic data code. You can do whatever number you have of classes. Okay, classes means if I have just 2 classes, so I have bird and animal. 5 classes, I have bird and sunset and animal and stuff. Okay, so and expected to develop dense and artificial neural network and the convolutional neural network from beginning to the final. All steps should be separated in Jupyter Notebook. You can just put the criteria. If I have 2 classes, you can put it like this, or just give me the link. And how the HTML file, you give me the HTML file and the Jupyter Notebook, and we'll run HTML file on this plagiarism tool to find out if there is copy or something, or ChatGPT generation. Okay, and how to do this? How to do this is the structure, the image collection, describe the image, where and you the source them. Don't put so much words, just 500 words is enough. This 10 marks. Image pre-processing, we just learned 10 marks. Dense neural network 14 marks. Develop initial convolutional neural network 14, and then hyperparameter. What's the hyperparameter? Batch size, number of epoch, the number of filter, and also the number of category, and making more convolutional neural convolution, or just 2 convolution, and after this maximal and another convolution and maximal and so on. Okay, change this, but give me initial one, simple one, convolution, maximal, then flatten, and one cellular and one output. Okay, and this after this hyperparameter, develop 2 further bigger neural network. I will show how I did it now. All right, and the final model run 10 example from unseen image. Okay, and calculate the performance accuracy using test set. Overall approach develop. So this how I marked it. Okay, must be taken to ensure work completely, and see that. Do you have a question about this, guys? I will still have 15 minutes more for convolutional neural network before I move to another topic.
Sorry, what's the deadline?
The deadline, it will be 10 days since I submitted. What's the
From
last
today?
one? What's the deadline? What's the deadline for the first one? Today?
Not sure.
It is submitted already, right? It's due already, right? The CA1 is due already. So I put this now, and the deadline will be after 10 days. Okay. And it is this easier one. You are not required to make any documentation, any document or any report, and also it is group assignment.
So are the three of us in one group?
No, two. The group is two person.
There's only three in the class. Someone's on their own.
But you know how many students here? I have 7 students here. So where is the rest?
Oh, I have no idea. I've only ever seen us three.
So
We haven't met any of them.
So I will. If we have 7 students, so we have 2 plus 2 plus 2, so 2 plus 2 plus 3. So I will accept just one group to be 3. Okay. But you guys, you should at the end of this one to tell me what's the contribution of each of you, if you wanna be 3 of you in the same project. Okay.
Is there any advantage to us being in a group if there's only the 3 of us, like, or are we better working off on our own? I'm kind of way behind on assignments across the board, and I'm just kind of nervous. Guys, to be honest with you.
Yeah, and even like finding the time to do it together will be hard.
Yeah.
So we cannot meet, so.
I know, yeah, because you are not every day together in the school, so.
Yeah.
No, yeah.
So since it's your decision, you want to be a group together, you want to be 2 groups, it's your decision.
3 groups of 1.
3 groups, yeah, 3 individuals.
I guess.
3 individuals, it will be harder for you. But yeah, but I don't mind for part-time student to be alone. All right, I don't mind. All right, actually, and this will not be. I will be easy with you if you are individual. All right, so I'll be easy with you, but please cover these things. All right, I will be easy for you. Right. So if I'm looking for the image processing for 2 person, not different than I get this image processing for 1 person. All right. So I know this overwhelming for 1. Okay.
Yeah.
Okay. So guys, today we apply many things. So this apart of 1 we apply today. It's part of it. Okay. But don't forget, guys, the hyperparameter. What is the hyperparameter? So the hyperparameter, I give you some hint of hyperparameter. This, what I'm going to do now, is hyperparameter. Copy. With this, I add more layers. So because the topology, remember topology, it's one of the hyperparameter. But this layer, let me say, this 32, this 64, this 64, this is correct. But I cannot say 64 and then 32. That's not correct. Okay? But I can say 32, 32, and 32, 64, 64, or 32, 64, 180, 28. Okay, that's correct. Another hyperparameter, change this number. Another hyperparameter, it changes the stride. Another hyperparameter, it changes the padding from valid to same. Same. Okay. Another hyperparameter, don't change this activation function. We used to change this before, but not here. Okay. I cannot change this. All right. Another hyperparameter, guys, to add regularization. So I will talk about regularization now, but let me first show you some more code, and I will come back to this. All right.
Just on the CA, talk, 500 images is across 3 different categories. Is that
I say it's 500 or 1,000. 1,000, I said. I think it's 1,000. Yes, the 1,000 image. Look.
Oh, okay.
1,000 image for all category. All your data set 1,000. Okay.
Okay, so like 300 per category, per class.
If you have 3 category, right? But if I have 2, just so 500
500 each then. Okay.
Or if I have 4, so 250. This minimum. If you wanna make more, it's okay. All right. It will not be easy for Keras to check for 10,000 or 100,000. Okay. It will be easy for Keras. It will be easy for Keras. Don't worry. Okay. Look here, guys. 1 second. Look here. This is the most trivial one. 1 convolution, 1 max ball, 1 flatted, 1 dense layer, 1 output. This is the most trivial one. You got this? I can make more complex after this. You got it? It's the most smallest one. All right. Let me here. I'm trying to find another code. Open. You know. What is? Okay, same. Open. With this. Oh, there's nothing here. Let me delete this. Catch. Yeah, it seems that's it. Okay, let me show you guys here another thing. This data set, guys, I will talk about another code called MNIST. MNIST. Okay, data set. What's the MNIST data set? MNIST data set, guys, is a large database of handwriting digits. So this MNIST, guys. Okay, so we train our model on the handwriting. So later, if somebody else write with his hand in our application, the neural network can recognize what is the number he tried to write. Okay, so I give these examples 1, 2, 3, 1, 2, 3. Okay, so how to do this? All right, let me show you how this is done. 1 second. I will open MNIST deep neural network. Yes, that's exactly the page I'm looking for. All right. So here, guys, the good thing about MNIST, you don't need to download it from somewhere because it is in dataset that belong to Keras. Actually, Keras has many datasets. One of them is MNIST. The other one is called the Fashion MNIST, and the other one is called the CFAR. CFAR, it is like some images with the small size. Let's see. So CFAR, and yes, this one, this data set, guys, it existed. Bird, cats, this existed in Keras, so you don't need to download it from anywhere. But of course, you cannot use it. All right. This is a small one. Also, we have dataset about the reviews for the movies by IMDb. Okay. Database, right? Okay. This a part of this reviews. Look, guys, this reviews. So I will teach you this in the next time. I hope I can do it today, but I'm not sure you are capable to do this with me. This reviews and see positive or negative. So this is important also, but I will not give you so much overall. Just I give you some images today. I will not move from images today. All right. So here.
I'm sorry, can I just ask you something? Because I'm just reading a footnote on the C2 document, and it says that the images must be manually sourced, that they cannot be from a public data science repository. So does it mean that we have to find them and just download them ourselves, or just take, if you look at the footnote of this page? No, just up. No, just a little bit more up. A footnote on first page. Oh no, you don't have it here.
So this how to, yeah, so if I come here, you will find the images here in the, this is an example. I give you example here, right?
Can you upload this CA to our Moodle page, because I think we have the old one.
I will do this now.
Okay, thank you.
Okay, before the last thing we do, I will ask you what's exactly the code I wanted to upload it for you, share it with you, and everything. That's thing I do. All right. Okay. Okay. This will be the last page I will talk about, this MNIST. All right. So I will show you how to do something here. All right. The MNIST here, it is a part of Keras. So what you need to download it from somewhere, just to say MNIST load data, so I can load it from Keras. Right. So I load the data in XTrain and YTrain and XTest and YTest. All right. Just here, I'm trying to show you from I in range of 5. Bring to YTrain. YTrain means the output. All right. The output here is 5. What is the XTrain? XTrain this image. The output 0. The XTrain this one. So this is the input and this is the output. This is the input and this is the output. You got my point, guys? This is the input and this output. So for the new input, your model will understand. For your new input, you can do this, right? Okay. How big the data train? The data set here, the XTrain just 60,000, and YTrain, by the way, it is and XTest, by the way, is 10,000. Okay, let me show you this. Copy. Code the XTest. What that means? This means we have how many images at all of them? 70,000. Why? Because I don't run this. It will take small time to load the data, not big time, about 20 seconds, I think. You're loading the data now. Okay, perfect. And now, what is the size? Is 60,000, and what is the test? Is 10,000. Look, guys. So this data set contains 70,000 images like this. All the images is 28 times 28. Okay. That's why it's look like this. How to do image pre-processing? Okay, as usual, guys. As usual. All right. I find the number of pixels for reshaping. Remember, for flatten, 28 times 28. Anyway, I know it is 784. Okay. And this, why? Where is the resizing? Where is the? I don't need resize. I don't need grayscale because the data is already resized 28 times 28 and grayscale. So the first tab already done. First tab. Okay. So, and what about to put it in X and Y? It's already done as well. X and Y, it's already done as well. Okay. So what you need to do here, I just reshape it right here to make the image one line. I reshape it, and then I normalize it. And here I'm trying to convert Y to categorical data. This all data pre-processing we need here. What did the others already done here? This data already 28 times 28. It's grayscale already. Okay, put it in X and Y. It is already in X and Y. Okay, so all you need to do this. It does X and Y a number array? Yes, it's number array. That's why I can find the shape. It is shoveled? Yes, already shoveled. What we need to do? Normalized and reshape. So this reshape for the both XTrain and XTest, and this normalized for the both XTrain and XTest, and this they put it in the categorical part, right? How to do dense neural network? Look here, guys. how it is easy. Look at there's the input size, and whether this input size and this the number of the first hidden neural network. What is the output? It's supposed to be 10. Why? Because I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 there. That will be the last layer. Okay. And this activation function should be max, soft max. Guys, I need to talk about activation function before I leave now. Okay, please don't let me to go before I do this. Okay, and activation function inside it is ReLU. Why? Because ReLU can make me avoid the problem of exploding the gradient or vanishing the gradient. All right, and also ReLU to avoid overfitting. Okay, so this is most simple one, and then compiling, training, and testing, and I printed the output. Can you please add here? Can you please add this? You can add it for me, please, to see the test. This if you add this part, guys, plotting part, so you can find the image of the accuracy in the test set and in training set here. Anyway, look, guys, I make something. The score here, I didn't calculate the score as usual. Supposed to calculate the score, right? I didn't calculate the score. What I calculate 100 minus score. So I calculate the error. So the error here, it was this much. Did I run this code? Let me run it. I think I need to run this. I need to run this, and then I need this data pre-processing. Then the dense neural network. This 10, it was 10 epoch, and this batch size could be make hyperparameter here. Look at the error, guys, 1.77. That's very good. Can you do simple neural network, convolutional neural network? Okay, and then I will do deep artificial neural network. You got my point here, guys. I'm trying to help you with your assignment to do how to make simple one and how to make it more complex one. All right. So this is the dense artificial neural network and this convolutional neural network. All right. We need here to conv 2D and max pool and flatten more than the one before. The other thing we already imported before. Okay. We do the random thing. This I load the data again, and I reshape it again, and I reshape the test again. What's the difference? The reshape here, 1 times 28, 1 times 28. But there is a reshape here. Look here, guys. This number 784. Correct, guys? The number of images and this number of 784. There's the difference between the convolutional neural network needs 2D, not 1D. Okay? And here, after this, I normalize the data as usual, reshape and normalize, and put this in categorical data. So I done with the data pre-processing here, because data pre-processing is a bit different in convolutional neural network in terms of reshape. That's it. Okay, here sequential, I make conv with the 32, 33, stride 1, valid, and this is the input shape. When I say that, I say the channel first. This means it's the number of channel, and then the width, and it's the height. Okay, and then I make max pooling, and then flatten, and then layer, and I would put layer with the 10 with the soft mix. So this is a very simple one. After this building, I compile, I train, I evaluate, and also here I say 100 minus the score to calculate the error. Give me small error, that's much. Okay. You got this, guys? You're still alive? Right?
Yeah.
But this yank up so hard. Yeah. Okay. All right. See here, look here, guys. I'm trying here to use something called the regularization. What does the regularization do? I will talk about regularization. So I need to talk about two things today, about the activation function and regularization. Or you want to keep it for next time, guys? I can keep it for next time, but please remind me, all right? This theoretical thing, needed for the exam. All right. Okay. Anyway, what is drop out, guys? Drop out to avoid overfitting. I can for the layer, any layer like this. Okay. I can add something drop out. What the drop out means? Drop out means this neural network, this convolutional, this by the way. Oh, so I'm sure these guys dense artificial neural network using drop out. Same code, this one and this one and this one. You just find this line is new. So I copy and paste it from here, guys. I copy this. Exactly. I saw it, right? I copy this and paste it here. Paste it exactly. You will find the same comment here, and I add this only. What that means? That means each iteration, guys, each epoch, your model will find 50% of this neuron and will delete it. What that means? That means each iteration he will delete different 50%. So your model will not be memorize the data, memorize this overfitting. You will understand the relation, not memorize data. Okay, it's called the regularization or flexibility. What the dropout for? To avoid overfitting. What the overfitting means? That means your model memorize the training set, and he will give you 100% accuracy for training set, but 30% accuracy for test set. This is very bad thing. To stop our model from memorize my data, I use something called the regularization. Memorizing the data set, training set is called the overfitting. Overfitting, high accuracy in training, low accuracy in testing. How to avoid this? Using regularization. Regularization contains dropout and L1 and L2. I will talk about dropout now only. Dropout right here. So this data set, this neuron is 784. So temporary for each epoch, you will delete randomly 50% of them. I can make it 20%. Of course, this hyperparameter. Hyperparameter I can't use. I can use it. So 20%. Okay. So each epoch, how many epoch we have here? 10. You will come here and you will choose different 20% of these neurons and drop it, delete it. So your model will find himself in different structure each time. You will not be able to memorize the data. You will understand the relationship inside the data. Okay? So this only thing we add here. And fortunately, it makes it was 1.77 error, now it's 1.73. Maybe if I working hard to change this number, maybe, and we can add more dropout here. So this is the model, guys. The dropout supposed to be inside the model. This is the dropout for this dense layer. I can make dropout. Oh, output layer, I cannot make this. Sorry. So I'm wrong, guys. I'm wrong. I cannot for output layer or this output. I cannot drop out after the output. Output is a 10 output. I need to know it is 0 or 1 or 2 or 3 or 4 or 5, 6, 7, 8, 9. Cannot drop any of them. Okay. Now I use CNN using dropout. So the CNN, okay, look guys, this data pre-processing for CNN, convolutional neural network, okay, and this was this. I copy and paste, and I remember this, and this convolutional, and this max ball, and this flatten, and this dense, and this dense output. I come here and they add the dropout. I can make dropout after the convolutional or max ball or dense layer, any of these. Okay, I make the dropout. It gives me better accuracy and less error. Here I'm trying to give you deep convolutional neural network. Deep convolutional neural network. That means I will add more layers. So here conv and max, and then dense and drop, and dense and drop, and dense and drop. Look guys, I used drop many times, and it's try and error, by the way. This try and error. Let me run this code. take time, but it will give me something, right? Here, guys, I say more deep convolutional neural network. More deep, yes. Again, guys, this is the data pre-processing, and here conv and max bool and drop, and conv and max bool and drop. So I add this. Okay, and this dense and drop and dense and drop and dense and drop. Okay, so this gives me if this small error less than 1%. What about this? Yes, it's 129. It's better. It's better than the one before. This one 174, 47. That's the error, but that's the most important. This is the most accurate one. Guys, do you have a question?
Lots of them. Get going on the CA now.
Okay, so listen now. I'll talk about two things. First thing, I would like to share this code with you. Okay, you will find the code here, but maybe you need my code, same code. Anyway, I will find the code here. When you say Keras, no, when you say Jupyter Notebook, so this is the first code. Okay, and then after this, sorry, after this, where is the Jupyter? Something on OpenCV, don't worry about this. OpenCV is not our point, all right? This does the pre-processing, all right? And now let's say how to make dogs classification. So we don't need this case, all right? I can hide it for you, but I need it. So the dogs example, it is right here. Same code we have, which is group 1 and group 2, all right? Step 1, but I will share with you my code because I arranged it to step 1 and step 2, all right? Also here, this is a convolutional neural network. Where can you tell me? This example of dogs here with a convolutional neural network, and also after this you will find, sorry for that, you'll find the MNIST. Yes. Don't look at this MNIST right here. But I will share my code with you because I show you how to make deep CNN, deep, not just CNN. Okay, so I will share many things with you now. I will start with the assignment. Okay, so I will come here to this one. Continuous assignment. CA2 right here. This is CA1, and I will make it here. Add assignment A2. Okay. Go here. And we need to take this download. No. Sorry. Okay, and we'll start for today, and we'll end at what you suggest to me, guys. Give me whatever you want. Today is, I don't have a calendar here, I think. So let's say 2nd of May, guys. It's okay.
Yeah, that's okay.
Yeah.
Yeah, it's 10 days, all right. And it's online and file submission, and it choose anything, any type, it's okay. Anyway, save the chain, and here, that's it. Save and return to course. As you see it. Okay, one more thing. I will come here, guys. Sorry, at the end here, okay, at the end before RNN, and I will add some of the code, like what, like MNist code, because the other code is
Deep, yeah.
the deep one, yeah. So share, and the copy link. Come here and I say, like this, copy. V, save and return to course. The other code, you will find it here, guys. Okay, I'll show you, right? If you need any other code, just send me and I can share it with you now, all right, in the chat. But already I shared this here, right? Here in this chat. Where is the chat? Okay, this is the first one. Next, share, copy link. It's supposed to be vice versa. It's supposed to be this last one, but make it first one. So do the example. Share, copy link, V, artificial neural network. But this one. So I have another one. Open notebook for CNN0. Okay. The first thing. No. Not this one. Share. Did you see the code in the shared the shared, guys?
Yeah, we can see that.
Okay, because the message didn't see it. So I think everything now you have it. So please come here. You'll find some of the code here. CNN for images. Okay. We don't have transparent, right? Just for images here. And we have the dogs example in this side, in this one. And the MNist is here. MNist at the end of Jupyter Notebook. Everything under convolutional neural network here. Okay. Right here. What else, guys? There's example for dogs here. Okay. And before this, we have data pre-processing. This pre-processing here, image pre-processing here, Jupyter Notebook here. Skip this one. Let me skip it with you. I will hide it so we don't need to look for this. And data dogs pre-processing here. Okay. I'm sure you are very tired. but I hope this covered everything for you. It's okay.
Yeah, thank you.
Do you mind, guys, to attend with the other student the revision in Monday at 3 o'clock? Monday, online.
It's 3 o'clock.
Okay.
Yeah, I think that's useful.
Yeah, I'll tell you one thing. I need 2 hours to complete the course with you, and we need another 2 hours, okay, for revision, because we skip the the class in the holiday. You remember the holiday, the Easter holiday, I think.
Yeah.
We skip a class, so this class make us back about 4 hours. So we need these 2 hours. We need 2 hours to complete something called the natural language processing in LB, and then we need 2 hours for revision. So
what day and time? Sorry, Dr. Assem.
So we have a revision time with the student, with the other student in Monday at 3 o'clock. Like
Monday.
if you agree, I will share the link with you. Okay.
That's the 29th. Yeah. Okay.
And also we need 2 more hours in Thursday to complete the rest of things, and they can take your question if you want. All right. So we have 2 hours in Monday and 2 hours in Tuesday. It's okay.
Tuesday next week or Thursday next week?
No, Tuesday. I'm sorry.
Tuesday.
I always mix between Tuesday and Thursday. Okay. And Tuesday at 6 o'clock, but Monday at 3 o'clock. It's okay with you?
Yeah, that's perfect. Thanks.
Yeah, I can do it. Yeah.
Send you the link once the student send me the link, because they will arrange the link and they'll send it to you. Okay.
Yeah. Thanks.
Yeah.
All right. Happy to meet you again. All right. See you.
So, yeah, thank you very much.
Thanks, Dr. Assem. Thank you. Thank you, guys. Take care.
Bye.